Let's go ahead and start example 6. This one will combine both the topics of decision trees and also probability trees. It's a bigger example, so make sure you read through the problem in detail. Pause the video if you need to. Go ahead and open a blank Excel spreadsheet, and I'm gonna make my decision tree in Excel. You can do paper. Either way is fine. These always start with a decision node. We make a decision. This one we have 3 decisions we can make, so I'm gonna grow is to have 3. We can approve the loan, not approve the loan for the customer, or run a credit check on them for $100. If I approve the loan, I'm going to take a chance on whether they default or not default on the loan. If the customer defaults on the loan, I'll lose the $10,000 I loan them. If I do not default on the loan, I'll gain $1,200 in interest. The problem says it's a 1-year loan at 12% interest. 12% of 10,000 gives me 1,200. If I do not approve the loan, the problem says I invest it in bonds for 6% interest. Therefore, my gain now is $600. The problem tells us the probability of a customer defaulting is 4%. Not defaulting, therefore, would be 0.96. If I run the credit check, events will happen with uncertainty. The credit check can either come back with a favorable recommendation or unfavorable recommendation. The probability of a favorable recommendation is not given to us in the problem. Let's take a quick break from this decision tree and sort out the information that they did give us. So the problem does give me the probability of D, 4%. I also know the probability of not defaulting, therefore must be 0.96. I've already used that in the problem. The sentence reads, in cases where the customer did not default on the approved loan, the probability of a favorable recommendation was 77 out of 96. So in probability statement form, in cases where the customer did not default on the loan, the probability of a favorable recommendation was 77 out of 96. Or in decimal, the next sentence, furthermore, in cases where the customer defaulted on the approved loan, the probability of a favorable recommendation was 1/4. So in cases where the customer did default, so given default, the probability of a favorable recommendation was 1/4, or 0.25. I'm going to scroll up quick. What I need is the probability of F. Just a favorable recommendation, and I don't have any of those here. So I'm going to use a probability tree to compute the probability for a single event, favorable. I start with the single event that I do know, default, not default, and put in those probabilities. Then my conditional probabilities I'll fill in after that, favorable and unfavorable. Favorable given default, 0.25, therefore this one must be 0.75. Favorable given not default is the 0.8021. 1 minus gives me 1.1979. After the tree, I want to get my joint events and their probabilities by multiplying the probabilities along the branches. So 0.04 times 0.25 gives me 0.01. 0.04 times 0.75 gives me 0.03. 0.77, 0.19 for each of those. Add them all up, they equal 1. The whole reason I'm doing this, I'm trying to find the probability of F, a favorable recommendation. To do that, I'm going to sum up the joint events with F in them. 0.01 plus 0.77 gives me a probability of F, 0.78. I can also find probability of F complement, or an unfavorable recommendation, 1 minus 0.78 to give me 0.22. All right, let's go back up to the tree and continue. So I need this 0.78 right here. And then the 1 minus. Okay, after I get a favorable recommendation, I still have a decision I can make. I can still approve the loan or not approve the loan. Again, if I do not approve the loan, I'll invest it in the bonds for a return of $600. If I approve the loan, I'm taking a chance on the customer, whether they default or not default. And I want to fill in these probabilities here. Now, be careful, this default probability here is not the 0.04 up here. This probability of D right here is conditional on a favorable recommendation. So I have to compute that probability by taking the joint over the given information. I have all of these pieces here from my tree. I need probability of D and F, 0.01, over the probability of F, 0.78. Gives me a final probability, 0.013. So that 0.013 goes right here. This probability, I'm just going to use the 1 minus button to find that one. If the customer defaults, I lose the 10,000 I loan them. If they do not default, I gain 1,200 in interest. Those numbers are the same from above. Now let's go down to an unfavorable recommendation. I still have a decision to make. I can decide whether to approve the loan or not. If I don't approve the loan, I invest it into the bonds for $600. If I approve the loan, then I'm taking a chance on whether they default or not default. I need to fill in these probabilities. And again, it's not as simple as we'd hoped. This probability here for default is not just probability of D. It's probability of D given an unfavorable recommendation. So I need to calculate that with the joint over the probability of unfavorable. From our tree, joint probability of D and F is 0.03. Probability of an unfavorable is the 0.22. For our final probability, 0.1364. 0.1364 goes right there. 1 minus gives me my probability of not defaulting given an unfavorable recommendation. The monetary outcomes are the same. Defaulting, lose 10,000. Not defaulting, gaining 1,200. At this point, I want to total up or net out each path. I'm going to put that in the U value column. I put it in the U value so that Excel will automatically calculate the EMVs at each green event node. As I fill in these numbers, Excel is automatically calculating the EMVs at each event node and choosing the best one indicated by the 3 arrows. The best EMVs it brings back to each decision node and then calculates a new EMV. So with the first decision, it's comparing 752, 600, and 968. The best EMV, 968. Therefore, the best decision right off the bat is to run the credit check first. We're also asked to calculate the EVSI and the EVPI. The EVSI we'll find by taking the difference between the EMV with free info and the EMV with no info. My EMV with free info I find by taking the EMV of where I purchased additional sample information, so where I got the credit check. So that would be the 968. But I'm assuming that it's free information. So that $100 that I paid for the credit check, I'm adding back on. Then the EMV with no info, I'm going to choose the best one, the best EMV with no info up here, which is my 752. the expected value of the sample information, or the expected value of the credit check, is the positive difference between the two. So the credit check is worth more than just $100 to us. It's worth $316. The EVPI, I'll find from the EMV with perfect info. This is a theoretical EMV where we're assuming that we know something with perfect information, that there's no uncertainty around our forecast. To calculate this, I say if I know for certain that the customer will default, the best option is to invest the money in bonds. That gives me a profit of $600. The probability of the customer defaulting is 0.04. I'm going to add it to, if I know for sure that the customer will not default, then the best option for me is to approve the loan for $1,200 and multiply that by the probability of the customer not defaulting. That's my EMV with perfect info. The EMV with no info is the same as the one used in the EVSI calculation, 752. The expected value of perfect information is the positive difference between the two. The EVPI represents an upper bound on the EVSI, so we should never pay more than $424 for sample information, because this perfect info is just theoretical. It's not possible to know something without any uncertainty.